My name is Yang. I'm a postdoc researcher in Utrecht University. I work in the group of plant microbiome interactions with Cornel Peterson and Roland Berdensen. So I have been doing research on microbiome since my master, so that's a long time ago. And for the current potato project, that started about 5 years ago. So this project actually started from a real life problem. Two of the most potato breeding companies in Europe, they came to us with the observation they have in the field. So what they observe is after they harvest potato tubers from different farmers, even these potatoes are from exactly the same variety, like they're genetically identical, but when you grow them in one single field, they show different growth. That's why we look into the so-called potato vigor to see that how we can explain why this potato grows so differently under the same condition. In this case, we define the potato vigor as how well the potato grows. So we trace the green canopy area after the potato germinated. So we use that as an indication about how potato perform. It's a measure to quantify the variation among different batch of seed potato tubers. Breeding companies collect all the seed tubers, then they sell them to all across the world to grow into new potatoes that we consume in the supermarket. The quality of the seed tuber is really important for all the farmers across the world, because otherwise they get a batch of seed potato tuber. They know it's from the variety Columba, for example, but they don't know how they perform in the field. So what we want to trace is how microbiome will influence the performance of these tubers. We can say it's related to the storage time. The longer you store, probably it will impact the vigor of the seed tubers. Then there are also a lot of pathogen tests. The problem is there's no really accurate and educated way to access the seed tuber vigor before actually growing them. But in this case, since we're microbiologists and we know that microbiome is so crucial for plant health, so we want to try to link this to find a new solution for predicting the variation of the vigor. So in this experiment, we collected seed potato tubers from 180 different potato fields per year. So in total, it's 360 fields across the entire Netherlands. Then we grow these tubers in 3 trial fields. So 2 in the north of Netherlands and 1 in France. So we don't only consider the climate in the Netherlands to measure the vigor, which here means the canopy area, which is the leaf region, measured followed by the drone imaging. In total, we could link these 2 data sets with random forest. So we use microbiome data collected from all these 380 different seed lots, which means batch of potatoes. Then we link to their growth within these 3 trial fields, Netherlands and France. Then we make the random forest to learn the pattern with the microbiome information. So in the end, we are hoping that we could identify the microbiome markers on that tuber to know that if it's a good batch or a bad batch. We did repeated experiment for 2 years. So we actually have microbiome data and the vigor data for 2 years. We could actually build a model on 1 year and use that to predict the potato performance in another different year. So this is really remarkable that this model can be applied even across years. So what we did is in the model's performance test, we use the correlation to show how well our model perform. If you see a very strong positive correlation, which means one batch, if it's predicted as a good batch, is more likely to be observed as a good batch. Yeah. So which means the model is performing well. During the communication with the farmers and the breeding companies, we found that as scientists, we think it's easy to understand, but for them, it's still very challenging to understand. So then we took one step further. We classify this performance into 3 clusters. So we cluster the performance of all the batches into low, middle, high. So in this way, the farmer can easily understand how to interpret the results, the outcome. Also, it's worth to mention that during the production of the breeding company, the most challenge is not you have intermediate batch. That's not a problem. The problem would really happen when you sell something as good, but it turns out to be bad. So The more important thing is the extremes instead of the middle range. Our model very nicely shows that we have trouble predicting the middle range since the variation is big and they are all not so good or bad. But for predicting extremes, the model is really performing very well. So for predicting extremes, the model can do 100% accuracy with many varieties. And for some varieties, it's also around 80 to 90%. So this will benefit the breeding companies. When they distribute these potato batches, at least they could know if I claim this is a good batch, for sure it's not the bad one.
Yeah.